While 2025 physics practical experiment number 1 mechanics is coming out from the topic Hooke's law and simple harmonic motion. So bring the camera, come close. This is my setup here. So I have the 2 roller required mounted appropriately. I have my 3 resistor stand. I have my G clamp. I have my stopwatch. I have my 100-gram mass label M concealed. And we are of the opinion, I'm of the opinion that this practical, what we need to do here is we are going to hang, these are the 2 loops they asked for. 1 loop to hold this ruler here, 1 loop to hold this one. This is my optical pin, and this is my helical spring hanging from this place with a pointer. I need you to come closer, come and show them my pointer here. Come and show them my pointer. Okay. Now see my pointer, my helical spring, and this is my M. So what we are going to do, we are going to hang this mass at strategic position. Okay, and then as we hang it, we're going to be measuring the extension on this vertical meter rope here. That's exactly what we want to do. Okay, all right, let's get to it. The first instruction said that we should put the first loop that is attached to the helical spring at a particular position here on the meter rope that is horizontal. So I'm putting this at 95th centimeter mark, and then by the instruction I was given, we are to suspend this one at 5 centimeter mark. Okay, second loop at 5 centimeter mark. Then once that one is done, we are to take the value of our Y naught, which is the original the extension the reading on the vertical meter rope. So let me do it very well. Okay, this should want it to be told. Okay, so I'm going to keep this throughout the experiment. All right, so you can come closer so that we can take the reading together. Hope it's not okay. Let's take it together. All right, now this is like 41.567. I think I need to move this. I want it to be exactly on the something I can read. Okay. This is 41.567. 41.7. So I will record my Y naught. Bring it here as what? 41.7 centimeter. Now once that is done, also don't forget that the distance between my point P and my point Q here is, I put this one at 95 and I put this one at 5 centimeter mark. Okay, that means the distance between P and Q is 90 centimeter, which is what I've recorded here. So this is the table of my value. So I want to look at I want to take a reading for this. The values could change, but let's just manage this for now. All right, or I might even increase it a little. Now, so what we're going to do, we now go take this our mass M here. We remove the loop here, and then we suspend it 5 centimeter from the other loop. So if I'm going to suspend it 5 centimeter from the other loop, so I put it in like this. So this one will be at 10 centimeter mark, and then this one will be at 5 centimeter mark. It's a loop. Let me increase it so that it can easily enter. And then it can easily. So let's tighten it back. Okay. And we are putting this one at 5 centimeter mark, and then we're putting this one at 10 centimeter mark, so that the distance between here and here will be 5 centimeter. That will be our X here, 5 centimeter. Now once this is done, I will now come to this vertical side and retake my reading. Don't forget I've recorded my y naught, so I want to take the value of my y now. So this one, taking this reading, this is 41.4 or 4, is it 0.5? Yeah, 0.5, 41.5. Okay, that's 41.5. Yes, let's take it as 41.5. Okay, so we call this one as 41.5. This one is 41.5.50 to 2 dp. Now let's do the same. Then I'm going to make it distance x to be 10 centimeter by adjusting this one to 15 centimeter here, such that 15 minus 5 will give us 10 for our x, right? So is at 15 centimeter. Let me make sure that it's vertical, it's totally vertical. Okay, good. I think this is good now. All right, trying to be sure. Okay, that's good. All right, now let's take our reading in this place now. So we take our reading. So this is 1, 2, this is taking from down, this is 41.1 to 41.65, 41, 1, 2, 3, 41.3, 41.3, this is 41.3, 41.30. Let's take the reading. Now we want to do 15 centimeter mark, so we adjust this one to 15 centimeter mark. So we take it to 20 centimeter mark rather. Okay, take it to 20 centimeter mark. Once it's at the 20 centimeter mark there, I have to ensure that it's everything, the ruler is staying vertical. Okay, okay, 40 centimeter mark there. Now let's come and take our reading on this place here. Let's take our reading. This is 41. That's 41 and 41.1 rather, not 41. 41.1. This is 41.1. 1.10. Now let's adjust x to be 20 centimeter. So this one, that means that this is moving to 25 centimeter, 25th centimeter mark. Okay, now we come and take our reading again. I don't like it oscillating. This is 39. Okay, sorry, 40.56, 40.5678, 40.80, 40.80. And then let's take the other one. Let's take the last one. So this goes to 25 centimeter mark. So that means that the distance between here and here will be 25 centimeter. So that means I should adjust this one to 30 centimeter mark. Okay, the weight M to 30 centimeter mark. Okay, it's there now. Let's come and take our reading again. So now I have 40.5, 40.6, 40.6, 40.60. Now they always ask us to evaluate our y naught minus y. So since this is our y naught, so our final values will be like this. You can see the value for, values for my x, my y, and my y naught minus y. So I have this. So the question asks us to plot the graph of y naught minus y against x. So if you plot that graph, we are going to get a straight line graph. It may pass through the origin or it may not pass through the origin. So where the slope of the graph is going to be S. Yeah. Now, there's something interesting about the slope. You see, by the time we get the slope, if we multiply our slope by this factor here, which is what? M over PQ. Don't forget our PQ. This is our PQ right here. The horizontal distance between the two points that we measured where we are taking our reading. Okay, mine is 90 centimeter. So that will be our PQ here. Then M is the value. This M here is the concealed mass. So, and then this K is the spring constant of the helical spring that we use. So if you multiply this, we get our spring constant from multiplying this relationship by the slope of the graph. All right. So don't forget, if you find this interesting and valuable, don't forget to subscribe to my channel. I'll see you. I'm still uploading a video on optics and electricity this weekend. Okay. Don't forget to like and share. Bye bye.